over here coughing up and on. Done.
This is in.
All right, let's see. Share my screen. Oh man, we got a full house. All right. Oh my goodness, this is the. All right, I think we're ready to rock and roll. Give me just one more moment. Ho, ho, ho.
It was online.
Oh. All right, gentlemen. So welcome. I am Professor Phifer, and this is Calculus for Business, spring of 25. A little bit about me. I'm an alum of Morehouse. I graduated from Morehouse, what was that, 2006, with a Bachelor's of Science in Mathematics, and then got a Master's of Science in Applied Mathematics in 2011 from Florida Institute of Technology, and then that's the extent of my education. So with that, I go by either Mr. Phifer or Professor Phifer. This is Calculus for Business, spring of 25. The main structure for this course is remote but synchronous, right? So we meet basically on Monday and Wednesdays from 6 to 7:15. I want to say this upcoming Monday is the King holiday, so we're not going to meet on this upcoming Monday. But then going forward, Monday and Wednesdays from 6 to 7:15. Let me actually jump straight to the meat of what you need. Yeah, and if you have questions, feel free to unmute yourself to get my attention at any moment, and we can talk about it. So I'm going to actually hop over to Blackboard. Let me see. So if we started like the Morehouse portal, and I go to Blackboard, and we log into our course, that'll serve as the central hub for basically everything that you need for concerning our course. I want to say that we have, what is it called? Not progressive, not aggressive. I don't know. I can't think of the word. It's along the lines of aggressive, but that's not the right word. But we have a quote unquote aggressive pace. We'll kind of play it by ear. I want to say, well, we'll see. We'll look at it. So when we log into Blackboard, we're here, right? So we're going to open up our folder. Oh my goodness, that is distracting. Come on, you'll be okay. So we're going to open up this main folder for Calculus for Business. So if you made it into the Zoom, that's the first hurdle, right? So that's the main first hurdle for all of us to get into the Zoom at the same time. So that's checkpoint number one. Let's see how to access our assignments. I think that's the next crucial piece. So we're going to be using MyMathLab. At this stage, being a student at Morehouse, hopefully by now, usually for like at least College Algebra 1, College Algebra 2, or pre-Cal, you may have had a professor that used like MyMathLab with we're not using Pearson McRory. So, okay, so you do have to purchase full access to this because it's a different book. If you had a professor in the past that used MyMathLab and it's the exact same book that we're going to be using, then you don't have to purchase access again. You can just log in with your credentials and it'll get you in there. But to access the assignments, you want to use this folder number 3 that says all assignments Pearson MyMathLab. I want to say it runs about $120. It should just be a one-time payment, and you can use it all semester. Let's open this. Let's open up this link and see what it looks like real quick. So, right now it looks like this. Now, I think you're
like in my side.
When you log in, I think your prompt might look a little bit different. It's going to ask you to log in or whatever. If it asks you to register, just register as a student using your Morehouse credentials. At some point, you're going to be prompted for payment. Again, it runs about $120. But once you get all the way in, you definitely want to go ahead and get full access. This stuff, you do not want to procrastinate. It piles up kind of quick. So let me go ahead and open my math lab. Okay.
Professor, did you take attendance yet?
That is a great question. So attendance is taken automatically via Zoom. It logs when you guys come in, when you leave, and stuff like that. So simple thing is, I try to be kind of low key. Just as long as you show up, I treat you like an adult, right? So as long as you're logged in, I don't push beyond that. So yeah, it's taken automatically. But at a baseline, I need you guys to just show up. And then if you're in out, I'm not going to make a big deal about that. Again, you're an adult, so I let you kind of work that as you see fit. But attendance is required. I think you're allowed maybe up to 3 unexcused absences. It's 1 unexcused absence per credit hour. So if this is a 3 credit course, it's 3 unexcused absences. If it's 2 credit, it would be 2 unexcused absences. But definitely once you hit 4 unexcused absences in either case, then you potentially, you know how that goes. Let me log in here real quick. Zoom. Join. Can I just join here? No, I don't want to switch. I just want to join. It's not that one. Not that one. There it is. Okay. Stay as a participant. Okay, that looks good. Okay. So again, once you gain full access to my math lab, it'll look like this. I want to say that all assignments for the semester are available right now. Okay. So with the exception of exams, right? So week 1, now I want to say for these first few weeks, I kind of gave an extension. Like today is really orientation. So we're just kind of getting our feet wet, getting access to my math lab. That's the main goal for today, is to get everybody access to my math lab, as many people as possible, full access. Now, I know some people use like a book voucher. So you can use the Morehouse book voucher. Just be sure to purchase like a My Math Lab access code from the bookstore. And then you can use that to gain full access. As long as you're going to have the funds to get full access within 2 weeks, then on the page where you're prompted for payment, there's going to be an option for get 14 days of temporary access. Then that's fine, as long as you're within 2 weeks of purchasing full access. So let me see if today is the 15th. Let me pull up a calendar real quick. So again, normally our assignments are due on a weekly basis. Like suppose this was week 1. I usually like to have assignments due at the start of class on Monday. So the next Monday will be the 20th, but we're not meeting that week. So, we're going to push that back. And then we'll officially get started with everything on the 27th. Now, but notice weeks 1 and 2 are already due on the 27th, right? Actually, not the 27th, sorry. We meet next Wednesday, right? So we have today, we're not meeting on Monday, but we are going to meet on next Wednesday. But for weeks 1 and 2, again, I granted an extension for at least week 1. So it's due at the start of week 3, right? On the 27th. So I know that might seem daunting because we have that day that kind of throws that we lose a day or whatever. So I already have something in place to address that. Let's hop back over to Blackboard. Go back to our central hub. So again, the landing page looks like this. Okay. So we've kind of looked at Pearson, and I know at the start of week 3 we have weeks 1 and 2 are due, so we lose a day. So how do you make up for that? With this item number 4 that says Professor Phifer's YouTube link, right? So my YouTube channel is called Beautiful Mind Phifer. You can just click on that link. It'll take you into a playlist. Basically, I have a pre-recorded lecture for every section for the entire semester, already ready to go right now. So this, even though we do meet on Monday and Wednesdays from 6 to 7:15, is really designed for you to learn on your own and go at your own pace. It's really designed that way. Again, with that YouTube link, those are my pre-recorded lectures. Anything that I intend to say live is already in those recordings. Basically what I did, I just took my time, and with each section, I went on and made a recording for everything, all the details that I wanted to say for each example. So when we have sessions, whatever we don't finish together, I do expect you to use my YouTube channel. Use that playlist to finish watching the necessary lecture, take notes if you're in class, and write down your questions, all right? So again, whatever we don't finish together, I do expect you to use my YouTube channel to finish out the lecture. So what that means is for weeks 1 and 2, at a minimum, you might want to go ahead and watch the corresponding lectures for those weeks. And you can actually see the necessary weeks in Pearson, right? So here in Pearson, you see it says week 1, week 2, right? And the corresponding due date is on the left. So weeks 1 and 2, you want to do your best to try to get those taken care of. Let me pause for the calls. Are there any questions for you guys? I don't know why it keeps audio keeps going in and out, but it's all good. Okay, so yeah, again, if you have questions, just feel free to either unmute yourself or type in the chat. I am monitoring the chat. I think there's also a Q&A. You can put it in the Q&A as well. Matter of fact, let me check the chat. Oh, yeah, no, you don't have to. Yeah, again, attendance is taken automatically. Now, another good idea, I always encourage the students to do this, and I know it serves somebody. I think a group meet or something along those lines is a great idea. I don't know if any of you want to spearhead that and put it in the chat for your brothers, but I think that's a good idea. My experience has been few students can like once you kind of get into the homework, you know, the students, when they come to me for help, it can be a hit or miss. But it seems like it's a lot more conducive when I have like a few students in the class that get it, and then let's use the technique of each one teach one. So like when I have a few students that get it, and then they work with their classmates, that seems to be the most effective. And I know that you guys are like up there as far as juniors and seniors and things of that nature. But let me just kind of say this anyway. So I found that like it seems like the best structure for students when it comes to me and like this kind of material, the order of protocol seems to be first do what you can on your own, just with the assignments and any kind of concept. You take it as far as you can on your own and be frustrated for a little bit, not too long, not too short. If you're not frustrated at all, then a lot of times nothing is sinking in. If you're too frustrated, then people tend to shut down. So just a little bit of frustration. And then once you've done what you can on your own, then maybe you can find a classmate that gets it, that's willing to work together. I don't really mind you guys working together. I just need each person to submit their own work. There was something else I wanted to say. Give me a moment. Okay, it's slipped my mind. It'll come back later. But yeah, you do what you can on your own. Then you link up with a classmate. Do what you can with the classmate. Pearson has a lot of support. When like the help me solve this, and it's like a lot of little learning aids inside of Pearson. So that for that reason is why I vouch for Pearson so heavy. It's extremely user friendly. Nearly every question comes with an explanation, like with all the details that you need to know. And then the quizzes and exams are basically a duplicate of the homework, just without the learning aids. It's a little bit different format, but it's the same stuff. So you've done what you can on your own. You've done what you can with a classmate. You've done what you can using Pearson and the internet. I want to say the tutoring service is included in your tuition. So, it wouldn't hurt to go ahead and seek out the tutors. I don't know that it's officially set up. I'll check something momentarily that you might be able to get ahead of that a bit. And then once you've done all of that, you've done what you can on your own, using Pearson, you've done what you can with the classmates, you've done what you can with the tutor. Then when you come and ask me the same question, I can give the exact same presentation as if you come to me initially, and it sinks in, all right? That's usually when it clicks, after you've gone through that process. Because then I can say it, and you're like, oh, I see what I'm doing wrong, But usually when students come to me first, they kind of get overwhelmed a little bit and they shut down. Not to say that you can't. You can definitely come to me first. Okay. So again, all of our assignments for the semester are available now, with the exception of exams. I want to say that we're going to have like 2 exams. So exam 1, exam 2, and a final. One potential extra credit that I usually like to do, provided I can do it at the end. I like to take your overall My Math Lab score and scale it and count it as 10% of your overall grade. So like whatever score Pearson says that you have, that's not your actual grade, but because I think the weights are different. But whatever score Pearson has for you, at the end, provided I can do it, it doesn't skew the grades too much. I like to offer that as extra credit. It's 10% extra credit. So potentially you can earn up to 110% out of 100% at the end. All of our assignments are unlimited attempts. The system is set to take your highest score, and all the assignments have an automatic extension built into them. So even though there's a due date next to each of these, I think the late penalty it's either 5% late penalty or 10% late penalty. So any question that you submit past the due date, there's that penalty that hits for that question. It's not per day, it's just per question that's submitted. Okay? So like if you submit an assignment late, the highest you can earn is either a 95% or a 90%. But I think it's 95%. Okay, so that's Pearson. Again, I'm trying to direct you to the main things that you need first while you're fresh, and then we'll go through other details momentarily. Okay, so we talked about Pearson. We talked about my YouTube channel. Let's see what's going on here.
Professor?
Yes.
I joined a little late. I may have missed it, but is Pearson's one of the ones you have to pay for? Like, do they have a free trial for this first like 2 weeks or?
Yeah, why is it doing this? Give me a moment. I think I'm gonna just close this one. Yeah, Pearson is paid. It runs about $120 one-time payment.
I appreciate it.
And it does have a trial that you can use, but I would only recommend that if you know you're within 2 weeks.
Yeah, 120.
I think so. Yeah.
All right.
I'm not sure. Yeah. Okay. Let's hop back. So courses, if I could change that landing page, that would be nice. Calculus for business. Let me see. Yeah, we'll talk about that in just a moment. I just want to get through this. This is the main things that you need. So we got into the Zoom. We talked about Pearson. We talked about my YouTube. If you ever need to share any files with me, you can use this Turnitin. Man, it is struggling today. You can use this student Turnitin, this folder, this item number 5. You can put it there, and I'll find it there. So we'll use that if you need to submit something to me. And then another piece of information, if we can get it working. Let me close this out. Okay. And so if you need to share documents with me, again, you would use that folder number 5, the student Turnitin. But when I go to share documents with you, like a copy of the lecture notes and any other documents that I want you guys to have, I'm going to put it in this folder number 2. This is basically Box. It's like Dropbox, but the Morehouse version of Dropbox is called Box. And it's basically file sharing. So let me go ahead and open this up. It should take you to like an external thing. You can use your Morehouse credentials to log in, single sign-on. And once you get into Box, it looks like this. So here's another copy of the syllabus. Let me put this in order of the name. Okay. Copy of the notes, past and present. So I think I left the old notes in there as a reference. And then, every time you see me writing something on the screen, I'm going to put it in that folder number 2. Once you all start requesting like help with the homework, any PDFs, I'll put them here in this folder number 3 that says answered homework questions. So I do a dedicated inquiries. So like when you ask the question for the homework, if you click on the Ask My Instructor in Pearson, it'll send me a screenshot of your question, and I'll make a dedicated video response, and I'll load it to my YouTube, and so that's why it's important to be subscribed to my YouTube with your notifications turned on. And then, it's free. It doesn't cost you anything. Shameless plug on my end, And then handouts, another way to access my YouTube. So then here, this last item, math tutoring, this is from the fall of 24. So if you're like wanted to try to get ahead of the tutoring, now this isn't official right now, like they haven't set up the tutoring, but there's a good chance that guys from the fall are also going to tutor this semester. So you can use this flyer and go to like Microsoft Teams from the portal and reach out to any student that's in that list and say, hey, are you available to tutor for calculus, right? Okay, so that's the meat and potatoes. Those are the main things that I wanted to touch on. Let me see. Yeah. So again, we talked about Pearson, my YouTube, Box. Those 3 links are the main ones. And Zoom, those are the main thing, the main items, okay? So now we're actually going to make our way through the syllabus and go through those details. I know I probably should have done the syllabus first, but anyway. All right, so Calculus for Business, spring of 25 with the CRN. Again, I'm Professor Phifer, Professor Charles, not Xavier. But sometimes I imagine, oh no, Charles, like X-Men. No, Charles, my brain. Ah, my face, my beautiful face. I don't know if y'all know that reference. That was an old meme. Anyway, from back in the day. But yeah, so again, I either go by Mr. Phifer or Professor Phifer. My email is firstname.lastname@morehouse.edu. These sessions are being live streamed to my YouTube channel, so you can actually go in you can actually find a copy of this on my YouTube, right? So if you go to the live tab, you'll find it there. And I think I usually make a playlist for each semester. So I try to put the live sessions into that playlist as well. But if I don't put it into that playlist, you can find it in the live tab. So, again, this is being live streamed. So just kind of be aware of that. My office cell phone is just a Google number, but you can call it or text it as needed. So I realize that a lot of correspondence, a lot of times students just needed a simple touching of the base. And, the email is like snail mail. And I'll be honest, I'm not really good about like following up on emails. Like I don't know. I get so much spam email across the board, even in Morehouse. I just kind of become numb to it, and I'm not the type to check it every day. So that's why I created, that's a dedicated like line. You can call it, text it anytime. If I'm available, I'll respond. If I don't respond right away, I'll respond as soon as I can. But that's the best way to get my attention, right? Is to text me. You can still send an email just to have it on file, but for the fastest response, call or text. My office is basically via Zoom. So where you are now. Did my Zoom number change? It should not have changed. Where can I find it? No, it's good. Okay. Let me check the chat real quick. Yeah, we got that already. Okay. And like, right, man, they have like really changed this, but that's all good. Okay. So office cell phone. So our goal for the semester when it comes to the text, we're trying to get through chapters 1 through 4. Is there a question? Going once, going twice? I think we're okay. Our goal for the semester is to get through chapter 4. All right. If this is essentially 16 weeks, so is that a section per week? 2 sections per week? Something like that. Anyway, but for the semester, right? We're trying to get through chapter 4. Let me see. So my office hours are basically Monday and Wednesdays, the 2 hours right before class. So if we meet at 6, I mean, honestly, you can call or text anytime, but generally I'm at my computer. I might not be logged in. If I'm not logged in, just call or text, and I'm usually available. We meet Monday and Wednesdays from 6 to 7:15 from today until I think May 9th. I think that's a Friday, right? So that's the last day of finals is that Friday, May 9th. So that's the hard deadline for all assignments. Remember me saying, there's an automatic extension built into all assignments, even though each assignment has a due date, but the hard deadline for all assignments is that Friday, May 9th of 25, okay? Okay, we talked about Zoom, that's all Zoom. So the prerequisite is either finite math, which is math 110, or pre-calculus, math 120 with a grade of C or better. We're going to be using Calculus and its applications, a brief version 12th edition by Bittinger and Kramer, or Scott, I guess. I'm not sure. I guess it's Kramer and Sargent. But again, this is all linked into Blackboard. And again, you access linked into Pearson, and you access Pearson through Blackboard. It's not really required, but we will use Microsoft Excel. So that's, part of the Office suite that comes included as a student of Morehouse. So as long as you have access to that .edu, you can use the Microsoft suite for free, even once you graduate. As long as you have access to your .edu email, you can use the Microsoft suite. Periodically I'll access stuff from graduate school. That was a decade ago. Man, it was a long time ago. Jesus. I blinked my eyes and it's already been a decade. It's crazy. Anyway, but yeah, that's how it goes. That's how it goes. Let's see, course description and outline. Okay, so this is our goal, right? What is that word I'm trying to think of? It's not progressive, aggressive. Yeah, I'll figure it out. So let's see. So chapter 1 is on differentiation. Let me say this on a differentiation. The derivative is just the slope of a tangent line at a point. All right. So that's the best way I could summarize derivative, the slope of a tangent line at a point. Now we have a lot leading up to that, a little bit of backstory, and it, at first glance, it can seem intimidating, but I want to say once you reach about section 1.4, like when we first introduced derivatives, one problem almost takes up a whole page, right? But then in like 1 or 2 sections, we start to learn the shortcuts. That problem that took up the whole page, you look at it and you automatically know the answer. All right. So once we kind of get into those shortcuts, that's when it kind of tapers down a bit. So, but yeah, this is our goal for the semester. We're trying to get through chapters 1 through 4. So exam 1, I think it occurs during week 6. Let's hop back over to Pearson real quick. Right. Did I close it? I think I closed it. Pearson right here. So let's see, week 3, week 4, week 5, right there. So week 6, exam 1 will become available. For 7 days, you'll be able to earn full credit, but after the due date, then there's like a late penalty. So exam 1 is going to cover chapters 1 and 2, right? During week 6, right? So I think that starts on like February 17th. Okay. So again, exam 1, chapters 1 and 2, and these are the sections, 8 sections in chapter 1 and 6 sections in chapter 2. Okay. Chapter 2, we're going to be applying different, calculus concepts to exponential and log functions. All right. So the derivative of an exponential and log and things of that nature. So that's the midterm. That's exam 1, right? It's during week 6. And then exam 2 is chapters 3 and 4. So chapter 3, so most of the semester is on different applications of the derivative, of differentiation. Again, the slope of a tangent line at a point. That's most of the semester, chapters 1, 2, and 3. Chapter 4 is basically the reverse of the derivative, right? So given a function, most of the semester, we're going to be exploring what do we mean by the derivative of a function. And then chapter 4 is like, okay, now we're given the derivative. How do we work backwards, right? That's what the integral is. And I feel like I would be doing you a disservice if we did not make it through integration in a calculus course, right? We need to get through integration. So again, all integration is doing the reverse of a derivative. How do we undo the derivative, right? So that's an oversimplified, summary of the course. Most of it is the derivative and different applications, and then we finish with the reverse of the derivative. It can be a little bit daunting, but there's a silver lining, and it does get easier. You just have to get through that little like learning curve. You know what I mean? So here we have a tentative schedule. So again, today is the 15th. We're just going to do the orientation. Now let me think. Is this? Yeah, that Monday is the King holiday. So if we didn't have that holiday, we would have done sections 1, 1, and 1, 2 on Monday, right? But we're not going to meet that day. So I do expect you to use my YouTube. Now for next week, our goal are those 4 sections. I probably will do sections 1, 1, and 1, 2 on Wednesday. We'll try to get through as much as we can on Wednesday. Whatever we don't finish by the end of Wednesday's class, you definitely want to be sure to use my my YouTube channel to watch those lectures. So this is basically the goal for each week. And so each week we're doing about 4 sections. That's an approximation. And again, you don't have to wait for me. You can go ahead and start watching those lectures, take notes as if you're in class, because I'm going to do the same thing live. So you don't have to wait for me. And you can actually go ahead and finish all the assignments for the semester. That way you'll only be waiting on the exams, and you just show up for attendance. All right? Okay. Let me pause for the calls. Are there any questions up to this point? I know it's a lot. I know I can be kind of intense, but this is what it is, right? This is our challenge. My style, I really I like to do where anybody that wants to find a way out, get whatever grade you want, I like to try to find some kind of way for that to happen. Whether usually, I already talked about extra credit. You get unlimited attempts on all assignments. There's a minimal late penalty, so you can submit. I've had students wait until the last minute and submit everything. I don't recommend that because one wrong move and you're screwed, right? But sometimes life calls for that, and it's okay. Do what you got to do. Let's keep going. So this is you can almost kind of use this as a Bible, your calculus Bible or whatever. So again, our goal for next week is to get through the first 4 sections. And then you can see for the first few weeks, it's 4 sections at a time. But then once we hit about the end of chapter 2, then it becomes like approximately two sections per week. So 1 section per day, right? Once we get kind of towards the end of chapter 2. Okay. You can see exam 1. These should be good. Yeah. Yep. Starts on the 17th. We definitely said that. So exam 1 is over chapters 1 to 2. It's available for that entire week. It's due on I think it's due on the 17th. It's either due on the 7th. The due date will be there when it pops up. I'm not sure. Now we have a Morehouse spring break is March 11th through the 15th. That should be the 2025. So I forgot that date, but that's okay. Yeah, so that 11th through the 15th is spring break. And I think that's it for the holidays. So we got this upcoming Monday and then spring break, as long, provided none of the other chaos. Okay. So we already know how to access Blackboard. Again, Blackboard kind of serves as our central hub for like our information. So whenever you're looking for something, you start at Blackboard. You can access the homework, any announcements I'm going to put in Blackboard, things of that nature. The grading rationale. So we're going to have 2 exams at 30% each. So I think that's a total of 60% of your grade. The homework and quizzes together are going to be, I'm going to count that as 15% of your grade. So I'm going to take I'll probably just take the average of all your homework and quizzes and then say times 0.15. And then the final exam counts as 25% of our grade, so a quarter of the grade. So the bulk of our grade comes from exams. The homework, even though it has the lowest weight, is the most important thing, right? Because that's how we learn here. It's just through practice. Practice makes what? Hopefully you're not thinking improvement, right?
Permanence.
Practice, dang.
Perfect.
No, it's not perfect. What was it? Oh, forget it. Practice makes improvement, right? I heard what you say permanence. It's not perfect though. Because if it were perfect, right, that means we would not have to practice again. And as humans, what happens when we stop practicing? What happens to our skill set? It goes down, right? So it doesn't make perfect. It just makes improvement, right? So the more we practice, the better we do. Every day as humans, we either getting better or we're not. We're either getting stronger or we're not, all right? So practice makes improvement, all right? Man, I'm definitely starting to get up there. I'm starting to forget things, man. It's okay. All right, so we talked about the grading rationale, some extra credit opportunities. Let's see, essentially 90s are A's, 80s are B's. Officially passing the course at Morehouse is a C. I tend not to give C minuses. If students are close, I try to find some way to get them over. They're usually missing like some assignments like, hey, you might want to submit this assignment like ASAP. You're like borderline. We're like, okay, and again, just try not to procrastinate. The best plan of action is to try to get ahead of this stuff as far ahead as you can. Like try to get ahead on like the lectures, the assignments. You don't have to watch those lectures, but if you want to see the lecture, that's the recommendation. But the requirement is, to get those assignments submitted promptly as promptly as you can. You can collaborate, you can work together, work with a tutor. I just need everybody to submit their own work. On my end, I'm just going to pull the data from Pearson, and that's how I calculate the grades. I want to say that Pearson, the assignments are linked to Blackboard, and I want to say it pushes automatically to the gradebook in Blackboard. All right, so once you start submitting assignments, the gradebook in Blackboard should update automatically. I've done it in the past, so this is like either my second or third iteration of doing this. So it should work. Again, we have assignments due on a weekly basis. Basically, assignments are due every week, generally at the start of class on Mondays. Again, this first week or so, I pushed it back just because we lose a day and things of that nature. And again, the homework is how we learn. And honestly, that's how I learned it. When I was a student at Morehouse, I did the work study working in Archer Hall. I don't know if y'all still do it this way or not, but when I was a student there, I worked in work study. And in Archer Hall, we sat at those desks and we basically checked people's IDs as they came into the gym. And so I told myself, I was like, well, hell, if I'm sitting at this desk for hours on end and they're paying me to sit at this desk, I might as well just go ahead and do my homework. So I got double paid to do my to do my homework. They paid me to sit at the desk for work study, and I was there on scholarship. So to keep my scholarship, I had to keep my grades up. And honestly, I kept most of my grades high enough by doing the homework. That was that fixed a lot of most of everything. Was just doing the homework. I didn't really study. I just did the homework. By the time I finished it, I knew it. You know what I mean? It's not like and I would still study for exams, but the homework was the bulk of it. So even though it had the lowest weight, it was the most important thing. And then it really, the comprehension level went to a whole nother level when I started tutoring. Because I had to think different. I had to put myself in my peers' shoes. Not that it's anything, I'm just telling you how I learned it, and you pick whatever works for you and then, move forward. But I by no means do not have life figured out in the least. I still got so many things to figure out. I spend most of my time gaming. I am a gamer. A lot of times if I'm late, it's because I'm trying to rush through a match. I'm trying to hurry up. So I play about I think it's 4 different games. The main game that I play is called Mobile Legends Bang Bang. It's a 5v5 battle royale capture the flag style game. The reason I enjoy it is because it's like a modern day version of chess. So if you ever study just chess strategy and war strategy and stuff like that, I'll use some of those techniques in the gaming. It's a lot of baiting and cooperation and stuff like that. It's a lot of fun, but it can be really frustrating. It's not for the faint of heart, and it's not if you're a student because you need to be focused on your assignments. But as an adult, I be, screaming and cussing. Oh, you stupid. It's a lot of fun though. It's frustrating, but it's fun. It's fun. So there's Mobile Legends, Dragon Ball Z, Dokkan Battle. I grew up on Dragon Ball Z, so but I don't do any other Dragon Ball Z, just Dokkan Battle because I'm trying to minimize my gaming because it's time consuming and it wastes a lot of energy and time. So I'm selective, and then I do a lot of Sudoku. And there's another game called Survivor.io. So that one's relaxing. It's just, zombies and stuff. So that's fun. And, sometimes, again, I'll use like geometry and rhythm and timing and frequency and chess strategy and whoever controls the center and, all this stuff just comes into play. Bait, sometimes I'll choose dopey characters and I'll just disappear. They're like, fuck. And then they're like right in the kill zone. I'll lure them into the kill zone and then, my teammates just pounce on them. It's so much fun when that happens. But yeah. So that's that. So again, we said there'd be 2 exams and a comprehensive final. All right. So we talked about that. Makeup policy again. We get unlimited attempts on all assignments, and all assignments have an automatic extension built into them. So if you want to earn up to 100%, you submit the assignment on time or early. But after the due date, then again, there's a late penalty for any questions submitted late. But then again, that hard deadline is that Friday, May 9th. Right, so that Friday, May 9th, everything locks out because on my end, I have to calculate final grades. Okay, so there's an automatic extension built into assignments. The last day to withdraw from a course is Monday, March 13th, the 31st. So is that about 2 weeks out? The last day of class is going to be Wednesday, April 30th, and final exam week is going to be May 5th to the 9th of 25. Okay, let me see what else. Attendance. Okay, so again, for attendance, we're allowed as many unexcused absences as there are credit hours in the course. I got to look up to see. I think this might be 2 credits. I'm not sure. But however many credits this course is, that's how many unexcused absences we're allowed. So it's either 2 or 3. So the 3 is a little bit of a grace. But if I start seeing that somebody has like 4 or more unexcused absences, then I'm like, okay. And then also Morehouse has this weird thing like about either the end of week 1 or 2, they want us to submit a report of like non-attendance and stuff like that. So it does this like purge thing. and then sometimes students get booted from the course and then they have a hard time getting back in, so just the simple thing is just show up and get your attendance. Just be on the call. Again, I'm real chill. Like I try not to single people out as long as you kind of let me do my flow and you show up and you can zen out and I don't make a big deal about that. Just try to keep the distractions and disruptions to a minimum and just listen. If you have questions, that's when you kind of stop me like, hey, wait a minute, this doesn't make sense, or can we talk about this? I was like, yeah, let's look at it. Yeah. Disability services, if you need any kind of special accommodations, you can contact the number at the end of that paragraph, and they'll give you a document that you can forward to me discreetly, and we'll make sure that you're accommodated. But again, this isn't really proctored. I feel like the intent or the structure here is this isn't like super rigorous. It's not like we're not in like proctored exams or proctored environments or anything like that, and you just have a calculator, paper, pencil, and stuff like that. It's really like where the real intent is I'm just trying to expose you to these concepts, and I got to make you accountable on some level, right? I don't really make too big a deal, so it's like just do the best that you can, but be sure. Again, I need everybody to submit their own assignments, but just do whatever you can do to get as much of this information to sink in as you can. Again, this is a remote course, so we're going to be using our devices. It's okay. Just again with the plagiarism, just do the best that you can. Again, on my end, my intent is just to expose you to these concepts and to get you to think about it and to get you to do your best. It's okay if you're working together. You can work with tutors. I really just need everybody to just at a minimum or at a baseline get your attendance, and everybody needs to submit their own work. But just be careful about like if you don't learn anything and you graduate and you get your degree, I don't know if you heard like a couple of years back, the president of Harvard, right? I mean, got all the way to the status of president of Harvard, and then it surfaced that they cheated in their dissertation. So then they lost that credit and they got fired. And then whoever took their place, apparently they cheated in their dissertation too. I'm like, what is going on, right? So it's basically a ticking time bomb, and it's not worth it. Again, I'm saying it's okay if you work together. Just do your best to learn as much as you can. My intent is just to expose you to these concepts and to get you to think about it. And I got to make you accountable on some level, right? So just do your best. It's going to be okay. I promise you. One of my former students, she would say, if you're talking to somebody and they're not saying what you want to hear, you're just talking to the wrong person. You just got to find somebody else to talk to. And I mean, I use that all the time. If I'm trying to get help in the store, or it don't matter what I'm doing. And if I'm talking to somebody and they're not saying what I want to hear, I just go, oh, okay. And then I just go and find somebody else. Either I just kind of diffuse and I just go and find somebody else to talk to about it. Another manager or higher up, somebody. You know what I mean? A syllabus is not a contract between instructor and student, but rather a guide to course procedures. The instructor reserves the right to amend the syllabus when conflicts, emergencies, or circumstances dictate. Students will be duly notified. Okay, we got a good 30 minutes. Right at 30 minutes. And so this last page of the syllabus is a document saying that you've gone through the syllabus, you understand what's expected of you out of the course, and that you'll abide by the rules of the course. This document, I do need each person to print it out. On the first line, you print your name again, and then print your name, sign your student email and the date, and submit that in and turn it in. Maybe I can offer some extra credit for that or something. But I need that document submitted. I need a copy of that from everybody. So you can submit this in and turn it in Blackboard. Okay. Again, if there are questions, feel free to unmute yourself if anything isn't clear. So with the last 30 minutes, I think I will go ahead and go through the first section, so we can get a demo on the structure, on the rhythm and flow. Okay, so I do need to go back and include those. Let me see, instructor notes. This one. So we'll go ahead and do this first one. Come on. If I can get it to work, because it is taking its sweet time. Nope. Okay, let me think. What else can I do? Select notes. That one. Duplicate. Okay. And that goes over here. Right there. Oh, come on. So the other thing is, anyway, I'll get in that later. Oh, come on. Calculus for business. So basically, Apple just did their update and they intentionally bricked my device, and so now it's like not working. And I know this will because it had been working fine. There's nothing wrong with it, but after the update, now it doesn't work anymore. And so because of that, it's just like I'm over Apple because it was clearly a marketing move, and like they've been sued for it before, and they don't care. They just keep doing it. Select, sort by. Come on, I know there's a way. I need this to move. What else could I do? Can I copy? I'm coming, guys. Select this one. That's a bit excessive, but whatever. Let's see. Share. See if this works. It usually doesn't take this, but I know why it's doing it. I hadn't figured out how to get around it just yet. No ability. Okay. Not that one. Right here. This one. Import. Okay, that's fine. I'll go with that for now. Matter of fact, let me just check and make sure it worked. It should have worked. I don't see why it wouldn't, but okay. Okay. Let me do this real quick. Yeah. Let's see. It's not there. Okay. I'll do another thing. Let me reboot this. Let's go. No, I'm good. Right here. Okay, let's see if it works now. There we go. I just need to reboot it. That's what happens a lot of times as well. Just needs to be rebooted. Okay, so let's see. This is week 1. Yeah, that's fine. Let me see. This is what, Monday at 6 p.m. 1.1 limits, a numerical and graphical approach. Okay. I'm going to do a shorthand. Calculus for business, Morehouse College Traditional, spring of 25. All right. I think we're ready to rock and roll. Okay. All right. So we'll go ahead and at least go through this first section. Let me see. Single page. Okay. So we'll make it as far as we can. But again, you'll notice that the stuff we do here should match what's in those recordings, right? So let's take a look at it. Let's see if that'll do it. Hopefully that'll do it without me having to go all the way up. Okay. All right. All right. So calculus and its applications, and calculus and its applications brief version, whatever. Chapter 1 on differentiation. So calculus and its applications. All right. And so section 1.1 is over limits and numerical and graphical approach. And the objective here, we'd like to find limits if they exist using numerical or graphical method, right? Can anybody describe the word limit? Like, what does the word limit mean to you? Like, just in your own words, what is a limit? Or where have you heard that used or anything? Like the limit. Take it to the limit, right? So it's like, the limit is like, okay, how far, like if you just keep going with this concept, what happens, right? So take it to the limit, right? So let's see how this plays out. So in example one, for each sequence, determine its limit and rewrite the sequence in the form as. Now this is red. Let me grab my pen. Here. So this is red. This symbol here. This is red as x approaches a from the left, right? So again, as x approaches a from the left. Okay. So, as we approach this number coming from the left, coming from the right, what number is it getting closer and closer to, right? So if we look at this first sequence, what number does it look like it's getting closer and closer to? If the first number is 2.24, and then 2.249, 2.2499, and then 999. So what number is it getting closer and closer and closer to? Looks like it was what, 2.25? Okay, let's go with 2.25. For each sequence, determine its limit and rewrite the sequence in the form as x approaches a from the left or the right. Okay, so this looks like it's getting closer and closer and closer to 2.25, and it looks like we're coming from the left, right? If we think about like a number line, right? Right, say this was 2, say this was 3, right? So basically it's getting closer and closer and closer to this number coming from this direction, right? So we can say what is x approaches a from the left would be that first one. Okay. The second one looks like we have what, 5.51, 5.501, 5.5001, 5.5001. So what number is that sequence getting closer and closer to?
5.5.
5.5, right? So it looks like it's getting closer and closer to 5.5. Are we approaching 5.5 coming from the left? If we think about the number lines, say we're on the number line, right? Positive x is in this direction. Here's 5.5. Are these numbers getting closer? Are they approaching from the left or from the right? Or in other words, are these numbers bigger than 5.5 or smaller than 5.5?
These smaller.
Yeah, these numbers are bigger. They're getting smaller, but right now they're bigger than 5.5. So if they're bigger, are they on the right-hand side or are they on the left-hand side?
Right.
They're on the right, so they're approaching 5.5 from the right. So the way we would write that, we would say what x approaches a from the right. So the limit is x approaches a from the right. In this case, will be 5.5. I'm going to get rid of this. Okay. All right. So let's see. One less than, is that like 2n and then 2n minus 1? So we have these series of fractions in C, right? We got a half, and then 3/4, and then 7/8, 15/16, 31 32nds, 63 64ths. So what would you say that sequence, what number is that getting closer and closer and closer to? If you had to guess?
1.
It does look like it's getting closer and closer to 1. That's what I would have said. So let's, not that I got any, I get these things wrong periodically. So, don't take my word for it. I'm just here as a guide. Cross-reference it. Don't take my word for it. You still got to do your own research, right? But yeah, it does look like it's approaching 1. Are we approaching 1 coming from the left or coming from the right? So I think all of these numbers are smaller than 1. So that means we are coming from the left, right? So as x approaches a from the left. Okay, let's see how do we do. Let's see how do we do. So we got 2.5, 5.5, and 1. We went left, right, left. Okay. 2.25. Okay, so as x approaches 2.25 from left, right? So it's read as x approaches 2.25 from the left. So I mean, what we have is fine, but it's the same thing. The second one is x approaches 5.5 from the right. And then the third one is x approaches 1 from the left. So, I mean, we got the concept, right? We got it. That's good enough, okay? Let me see. So the definition of a limit. As x approaches a, the limit of f of x is written as L. Is written as the limit. Here, let me do it like this. The limit as x approaches a of f of x is L. Okay. Let me read that one more time. So as x approaches a, the limit of f of x is L. If all values of f are close to L for values of x that are sufficiently close to but not equal to a, right? So what this is referring to, if we think about like an xy plane and we have some function, right? And I'll just do a rough sketch. I'll do it in purple because I'm just making this up. So say this is like a positive x, this is our positive y in this direction, and we have some curve, right? We have a curve. And we want to consider, you know, here's our a, right? And so as x approaches a from either side, right? So as we get closer and closer to a from either side, right, our y values get closer and closer to some L value, right? Essentially, that's what it is. So like as x gets closer to a coming from the left, y gets closer to L coming from the bottom. As x gets closer to a from the right, y gets closer and closer to L from the top, right? So that's essentially what's happening. As x gets closer to a, what's happening to our y value? I'm gonna leave that in. And again, I'll make a copy of this available in a Blackboard. Use that box link, and you'll find a copy of this there. So as x approaches a, so we have this theorem. As x approaches a, the limit of f of x is L if the limit from the left exists and the limit from the right exists, and both limits are the same number L. That is, number one, the limit as x approaches a from the left equals L. Number two, the limit as x approaches a from the right of f of x equals L. And then ultimately, that means that the limit as x approaches the limit as x approaches a of f of x equals L, right? So to summarize that, in order for a limit to exist, the limit from the left has to exist, the limit from the right has to exist, and those two results have to be the same. Sometimes what you'll find is coming from the left, we get one answer. Coming from the right, we get another answer. So then we say that the limit does not exist in those instances, right? So again, in order for the limit to exist, it has to exist from the left, it has to exist from the right, and then those two outcomes have to be the same. Okay? Let me see. So given this function, okay, first we're asked to evaluate f of 3. What's the time? I'm watching the clock. We'll hang out for about 10 more minutes, right? We'll hang out for 10 minutes. So what is f of 3, right? So, we're just going to evaluate this when x is 3. So I'm just going to do f of 3. I'll just do it here. 3 squared minus 9. 3 up. Now look, what happens when we do 3 minus? It's undefined, right? It's not defined. So we'll say does not exist, right? Because we get a 0 in the denominator. So at 3 is not defined. All right, hopefully that makes sense. If anybody's not clear as to why that's the answer, just let me know, right? So it's not defined at 3, but then we ask what's the limit of f of x as x approaches 3. So we can explore this as x comes from the left and as x comes from the right, as x approaches 3 from the left and from the right. For introductory purposes, a simple way to do it is like to create a table, right? Table of values, like say you did from the left first. Let me see. So you would have your x versus your f of x. So as x approaches 3 from the left, right? So we can start with something like, if we're coming from the left, we might do when x is like 2.5, and then when x is like 2.9, and then 2.99, 2.999. That'll be enough, right, for now. So we can make a table with those x values, find the corresponding y. That's coming from the left. We should get a result. And then we also want to do it, I'll do a different color, coming from the right. So we're gonna have our x versus an f of x. Now, if we're coming from the right and we mimic the concept or whatever, we can start when x is 3.5, and then what, 3.01. Actually, let's back up. When 3.1, 3.01, and you see there's no limit to how many times you can add zeros. Conceptually, right? So then we can like use our calculator to generate those numbers. Let me see. Oh, is it? No. Let me go full screen. Do this one. I agree. Choose the file. Where is it going to be? It's going to be here. There it is. Done. Okay. All right. Schoolish. Okay. So let's like explore this in the calculator, right? So on top we have what, x squared minus 9 divided by x minus 3, right? Okay. So, I'm using the TI-83 plus. This is a virtual TI-83 plus or whatever. And I'm going to evaluate the function at each of those results or each of those x values. So the way I like to do it, on the right-hand side of the calculator is the clear button. To the left of that is the button that says VARS. I think it's short for variables. I'm going to click on that. I'm going to go to the right to go to Y variables. I'm going to click on number 1 for function. And I think we put it into function Y1. So now I'm calling on that function that we just typed in a moment ago. And so basically I want to evaluate, I'm going to do an open parentheses. I want to evaluate this function when x is 2.5. I should do close parentheses, but I don't have to. You can just hit enter. And so when x is 2.5, the corresponding y is 5.5, right? So here I'm just going to put 5.5. Okay, let's see when x is 2.9. We get 5.9. All right, that's a huge hint as to what this is approaching. Let's go ahead and tack on another 9 there. So 5.99. Let's do another one. Tack on another 9. All right, so now coming from, as x approaches 3 from the left, it should be clear that, we can see our y values are approaching a certain number, like from the exercise we did a moment ago. All right, let's see if we get the same number coming from the right. So now let's start when x is 3.5. So I'm gonna just, I'll just delete these. Okay, we said what, 3.5? Okay, slightly more than 6. That confirms, hopefully what we were all thinking. Let's do 3.1. Oh, clear, recall. 3.1, 6.1. Let's do 3.01. 6.01. 001. Okay. So it should be clear, right? As x approaches 3 from the left, y gets closer and closer to 6. As x approaches 3 from the right, y gets closer and closer to 6. So what's the limit of f of x as x approaches 3? You see. So as x approaches 3, the limit as x approaches 3 is of f of x is 6. All right, and we really should do something like we should tack this on something like this says the limit as x approaches 3 from the left, from the left of f of x, that equals 6. The limit as x approaches 3 from the right of f of x also equals 6. So because the left-hand limit exists and the right-hand limit exists and they're equal, then we say that the limit as x approaches 3 is 6. The left-hand side has to equal the right-hand side. Let's hang out for 5 more minutes. So now we did it on our own. We had some prepared notes, right? We had the answers already there. So since this function, if we substitute 3 in for x, we get this. We get a result. It's not defined when x is 3. So even though when x is 3 itself, it's a hole or a gap in the graph, it doesn't exist at that point. But the left-hand limit exists and the right-hand limit exists, and they're equal, right? So first, as x approaches 3 from the left, you can see the same thing we just did just a moment ago. And then as x approaches 3 from the right, they started at 4, which is fine, but they essentially got the same thing that we did. So since both the left-hand and right-hand limits agree, then we can say that the limit as x approaches 3 of f of x equals 6, right? Left-hand limit equals right-hand limit, okay? So limits, that narrative is, we're concerned. I mean, we do explore what happens exactly at the point, but a lot of the discussion is what happens when we're like close. Like if we go slightly to the left, slightly to the right, what happens when we're close to these values, right? Like if we were Ant-Man and we zoomed into the quantum zone, will it still behave the same way? Conceptually, yeah, right? We're talking about different types of infinity here, right? So as we get closer, infinitesimally close to these numbers on either side, how is it behaving, right? Okay. We'll go ahead and make this the last example. Hopefully we can get through it quickly. Consider this function given by h. We're asked to graph the function and then find each of the limits if they exist. When necessary, state that the limit does not exist. So this is a piecewise function. I know I could do it there. Okay, so I'm going to introduce another learning tool. This one. So it is possible to do it in the 83 plus, just for the sake of time, because I don't remember right off the top of my head. I'd have to look it up a little bit. I'm gonna use. I'm not sure if you ever use like a Desmos. I know a lot of students like to use. So, and it's free. It's a free virtual graphing utility. I'm just gonna click on Open Graphing Calculator, and I'm gonna use this as my little tool. Just for the sake of time, if we can get it to open. This is a free tool. Okay. Trying to remember how to do it here as well. Okay. Let me see if I just type 2x plus 2. What if I do a comma? I'm going to have to look both of these up because off the top of my head, I don't remember how to do it. No. Okay, I'm gonna have to look it up. Let me put a pin in this. I got like 2 minutes, a little bit more than 2 minutes. Just give me a moment to see if I can look this up. Let's do the TI-83. So TI-83 plus piecewise function. Okay. So x plus 1 as x when x is less than 2 plus that one when x is greater than 2. Okay. Okay, we might be able to do it in the TI. This one. Okay, let's see if we can do it here. So I'm going to go to my y equals. I want to check one more thing. Okay, I think those are parentheses. Okay, let's see if this works. So we're going to do parentheses, and I know we can do this by hand. I just wanted to showcase at least one of these. Let me check one other thing. Let's just keep going. So we're going to do parentheses. X is less than 1. Where's the less than? I think I got to go to math. Test number 5. Okay. I'm gonna say plus parentheses 2x minus 4 parentheses when x is greater than or equal to 1. So I'm gonna say x test number 4 greater than or equal to 1. Okay, let's see if this does it. Okay, let's hit graph. See what happens. Got our positive slope. Okay, so keep in mind that that's going to be like a hole or a gap, right?
LeBron James.
We're about. Oh my goodness.
This man right here. LeBron is ass.
Come on. All right. Right. So again, the first one is 2x plus 2, so it has a slope of 2, y-intercept of 2. But then there's going to be an open circle when x is 1 for that one. And then the second one is going to be a closed circle when x is 1. It still has a slope of 2, but now the y-intercept is negative 4, right? So there's going to be a hole or a gap. Now, I'm just looking at it. Let me see. So the limit as x approaches 1. Now, from the left, right, we would use that first one, that first line. So as x approaches 1 coming from the left, it's like our y value is approaching, what is that, a 4? But then as x approaches 1 from the right, it's like it's approaching a negative 2. So for part A, the left-hand limit exists, the right-hand limit exists, but they're not equal, right? So for part A, the limit as x approaches 1 does not exist. But then for B, the limit as x approaches negative 3. So when x is negative 3, we would just use line 1, right? So then in either case, as x approaches negative 3, negative 6 plus 2, negative 4, the corresponding y would be negative 4. So coming for part B, as x approaches negative 3 from the left or from the right, in either case is going to approach negative 4. But for part A, that's on either side of that gap, and they both approach different numbers, right? So A, no, the limit does not exist. B, the limit is, I think, negative 4. So first, for numerically, right, as x approaches 1 from the left, so they chose those x values from the left. They found the corresponding y's. From the left, the y value was 4, right? That's what we said a moment ago. But then from the right, again, they chose those x values, found the corresponding y, and it approached negative 2. So the left-hand limit exists, the right-hand limit exists, but they're not equal, so we say the limit does not exist for part A. So the limit does not exist. And then for part B, right, is it there? Yeah. In a numerical sense, so they did the table again, they chose those x values like we did in that second example, found the corresponding y. From the left, it approaches negative 4. From the right, it approaches negative 4. So because the left-hand limit equals the right-hand limit, and they're the same, then we say the limit exists and it is that number. I was using this technique called like the wall method, where you draw a vertical line. Like when x was 1, I was visualizing like a vertical line, and then coming from the left, the line hit like at 2 or whatever that number was, or 1, and then from the right, y hit like negative 2. So they didn't hit at the same point on that wall. So that's why that limit didn't exist. But for the second one, when I drew the wall, coming from the left and coming from the right, they both hit at the same point. All right, I know we're kind of out of time. That's why I was trying to be a little bit quick, and we got about halfway through. Right, let me kind of showcase this real quick, and then I'll close out. I guess let me get a different color. Right. So, like for instance, what I mean by like the wall. Oh, you can't see that. I see the time about to get you gentlemen out of here. So for instance, when x for the first one, when x was 1, coming from the left, our y value is, what is that, a 4? It approaches 4. And then coming from the right, our y value was negative 2. So because the limit from the right does not equal the limit from the left, that's why that limit did not exist. But then for the second one, when x was negative 3, if I use my same wall, notice that they both hit at the same point, right? As x approaches 3 from the left, this is the corresponding y. As x approaches 3 from the right, same corresponding y. So because they hit at the same point, then we say the left-hand limit exists, the right-hand limit exists, and they're equal, so we say the limit exists, okay? All right, are there any burning questions before we go our separate ways? I'll make a copy of this momentarily. So again, attendance is taken automatically in Zoom. As long as you get in and send out, I don't make a big deal about that. We'll meet again. So I think Monday is a holiday. It's a Martin Luther King Day, so the school is closed. So we're going to meet starting again on Wednesday. We did 1.1. Well, we got halfway through 1.1. So when we come back on Wednesday, more than likely we'll start with like 1.2. We have 3 sections to get through on that day. Obviously, we're not going to get through 3 sections on that day. So whatever we don't finish together, I do expect you to use my YouTube recordings because after next week, I'm going to go ahead and start with section 1.5. So we'll do what we can together, but I do expect you to use my YouTube for whatever we aren't able to do together. For right now, it's best to just go ahead and complete sections 1.1, 1.2, 1.3, 1.4. And so that way you can be ahead. That way we can use class as a review. And when we start on that following week, you'll already be in position and ready to go for section 1.5. Okay, if there aren't any other burning questions, we're going to go ahead and end the session here. And now from one beautiful mind to another, have a great weekend, gentlemen, and I'll see you in 7 days. Take care. Peace.
All right, thank you, Professor.
Thank you.
So I got a quick question.
Yep.
Like when you use that calculator, like is that on your YouTube channel? Because I didn't really understand how you did the calculations. Like I understand what you did, but I don't know like how you use the calculator. Like do you do that on your YouTube?
I don't know that I did that exclusively. Now, you mean like which one? Like the piecewise function or the
second one, like the second example we did.
With the table?
Yeah.
Okay. Let me pull it up real quick. We did a quick check. Is that what we did? Here it is. No. This one or the other one?
That down right there.
This one? So, in the previous one, I made it, but you said you wanted the table.
Yeah. Yeah,
Okay.
it was like I don't know how to like use the calculator to get to that point, is what I'm asking. I don't know if that makes sense or not.
No, it does. So, all right. So, for instance, for part A, they wanted the limit as x approaches 1. So if we want to find the limit as x approaches 1, we need to investigate, as x approaches 1 coming from the left and coming from the right. So remember in the previous example, we made a table, right? Let me go back to that example. Right here. In this blue and orange, we did it manually, right? So we chose those x, right? So if we wanted as x approaches 1 coming from the left, we could start at either 0 or start at a half, right? I probably would have started at a half. Or like 0.5, and then I would have done 0.9, and then 0.99, and then 999, similar to this, just without the 2. So then I would have used the calculator to calculate those, right? So let's do that real quick. Let's do that. But it's basically just a table. Okay, here, right? So if we want the limit as x approaches 1, so let's start it from the left. So like we got our x versus our h of x. If we want to coming from the left, this is from the left. We can do like 0.5, right? And then like 0.9, and then 999, 999, and that should be enough there. Right? So we chose those x values. Now in the calculator, what we have is fine. So I typed this in basically for it to be a piecewise function, right? The first line is 2x, I guess it's 2x plus 2, right? 2x plus 2, when x is less than 1, plus 2x minus 4 when x is greater than 6. So I just did 2x plus 2 in parentheses, and then another set of parentheses when x is strictly less than 1. For that less than, I did on the left-hand test. So math, I hit second math to open up this logic kind of thing. That's how I got those symbols. And then plus the second line, and that's the piecewise function. So then if I wanted to use a table, I'm gonna go back to the home screen. I'm going to click on my variables button. So it's slightly to the left of the clear button. I'm gonna click here. I'm gonna go to Y variables to the right. I'm gonna click number 1 for function and number 1 again to call in the function that we just used. I want to evaluate this function when x is 0.5. Okay, let's see what do we get when we put in 0.5. Now we got a 3. All right. So when x is 0.5, we got a value of 3 here. Now I want to evaluate it when x is 0.9. So I'm gonna just recall and do 0.9. We got 3.8. Okay. I'm gonna do 0.99. So I'm gonna recall and tack on a 9 and then submit. So 3.98. All right, it's kind of manual. 999, 998. Right? So that implies that as x approaches 1 from the left, our y values get closer and closer to 4. Now we need to go back and do as x approaches y from the right. Right. Okay. So we'll
No, I see. I understand.
this. So
I just didn't understand how you like.
got it.
Yeah, yeah. I just didn't know how you put it into the calculator, but I see now. I guess I just missed it earlier. But I understand how to do it and everything. I get all that.
No. Yeah. So and again, this technique is like introductory. It goes a lot faster. This is just like an introductory technique as far as making the table, but we'll start exploring like much faster ways to go through this. It'll start to sink in, and you won't really have to do the table like that every time. We have some ways that are more sophisticated.
Yeah. All right. Thank you, though, Professor. Have a good one.
Yep. Take care. Any other questions, gentlemen? Once. All right, gentlemen. So again, I'll see everybody in about 7 days from today. All right. Take care. Peace. All right. Let me check the chat real quick. Nobody did a group me. I just noticed. That's okay. I wonder why is he crying? Oh, where is this thing? Here it is. All right, guys, take care.